In this video, I'm going to talk about a makeup air unit that we have on a current project. So the makeup air unit's purpose is to bring in fresh air from outside into a building or space. This unit here has a series of chambers within it that all have certain responsibilities in what it's accomplishing to make it work. So I'd like to break down what each of those chambers does. But just to talk about it, in this application it's a rooftop unit. So I have that outlined here. It sits on a platform or a roof curb, as we call them. So if we're taking in fresh air, that travels through the unit and gets discharged into ductwork to serve the space that it's going to. So inside of that curb is an opening into the roof deck for the ductwork. Now, a couple other utilities that we have to get to that unit are power to turn the unit on and off. We need controls, so we know how to control it. And then we also have hot water supply and return, so that we can treat that incoming air before it goes to the space. So in this one, this is a fire hall project, and this makeup air unit serves the apparatus bay where the truck engines are. So in the wintertime, when the garage bay doors are open, this unit will serve as a heat source for that space while the garage doors are open, so that you don't lose all of the heat when they're open. So this won't run all the time, but you certainly need a heating element to treat that outside air, in the wintertime, to warm it up before it hits the space. So if you look up here at the top, I have defined all the chambers of the makeup air unit and what they do. So our outside air coming in, there is a weather hood here. Then we have our V-bank filter rack, which has the filter rack has those filters in the V shape versus your standard flat, which is pretty common. Then you have your damper. This will open up. This will be a louver that opens and closes the fins of it to allow air to pass through. When the system's off, that damper will close. Then we have our hot water coil that allows our hot water loop to pass through the coil and treat that air coming in. Then we have our control center, which comes with a disconnect switch and a VFD and a controller integral to it. And then we also have our supply air fan chamber here that draws the outside air in and pushes it down to the ductwork to serve the space. Next, I'd like to talk about the controls, how the system's controlled. So I'm going to touch base here on the power first, and then we'll get into controls. So from a panel in the building, we have our 208 power to be able to turn the unit on and off. That runs through a pipe portal on the roof, and it terminates at this disconnect switch. So this disconnect switch, let me zoom in on that. That disconnect switch right here will be your on and off. So this will be an access door up on the roof. So that'll be our on and off to the unit. Then we have down here the controller. So we take that 208 power and that goes to this VFD. This VFD will be the signal caller to the fan on what it needs to do and when. So when we send a control command, it will ramp up or down according to what we're telling it to do. So the internal control here, this controller takes all the data from the unit and brings it into one central place here where we can interact with it. So somewhere in the building is going to be a building management system, and that building management system panel will have wiring running from it that goes up into the unit and goes right to this controller. And what that'll do is be able to give us a way to communicate remotely with this unit. So depending on what our desires are, or what the facility's desires will be, they will make adjustments according to that. So for the controls, there are, let me slide over, there are some control points here. So the control points on here would be your outside air damper. So that's going to open up your airstream or close it depending on what it wants to do. This is a outside air temperature. We'll monitor what the outside air temperature is. Your filter differential pressure will be 2 probes. One will be on the inlet side of the filters and one will be on the discharge side of the filters. And it will compare the two to let you know how bad the filters are plugged up. You have your supply fan status, which will tell us whether we have power to the supply fan or not. This will be a start-stop function for that same supply fan, so we'll be able to turn it on or off. And then your supply fan speed. This will allow us to determine how much RPM we want to put to the fan based on the CFM that we desire to the space. Then we also have a freeze stat, which will be on the back side, or the discharge side of the coil. This I don't know, this looks like it's electric, okay, but basically there will be some capillaries on the discharge side of that coil that we can keep a monitor if we have any frost buildup, etc. Then we also have a leaving air temperature point as well. So those points I took and put them as it related to the unit itself. So I'll zoom in here. Let me slide over. So our outside air damper, 0.1, is here. So that damper opens and closes as the controls require. 0.2 is our outside air temperature sensor. So we have a probe out here as that outside air comes in. That's telling us, what the temperature is outside. Our filter differential. So we've got this V-bank filter rack. So we're going to have a probe on the inlet side and a probe on the outlet side. And that will send us what that difference is back to the controller. And then 4, 5, and 6 are all fan related. So those are all right here at the fan. Our freeze stat, like I said, is on the discharge side of this coil. And then our leaving air temperature sensor will be a probe down here where the treated air is pushed down to the space. So just to wrap up the controls side of this, oh boy. I'll show you down here. We got alarms. So we got the trending. So these 4 X's here on the trend will be saved in the building management system. They will keep a constant log of what those are doing so that if anything happens, you can always go back and see what it was doing and when, what time of year. So it gives some ability to fact check what's going on if there was issues. Then also they have an alarm here. So these 3 points here with X's will be alarms if they end up failing. So on the BMS side, those were just two important things that you should know about as well. So before I talked about how this was, the air coming in was treated across a hot water coil if we have to warm up the temperature of the outside air because it's treating that apparatus bay like we talked about. So there is a glycol system that's heated by boilers. There is a 3-way valve here. So obviously when it's in when it's trying to make up air for that apparatus base. Depending on what the outside air is, would this three-way valve would allow glycol as required to go through the hot water coil, or it will just bypass it altogether. But so this pipe portal here is up on the roof as well. It sits close by to where this roof curb is, and what that'll do is allow us to have an access point to run our piping up through the roof and connect over to the coil. And it also allows access for our electrical contractor, power contractor, and our controls contractor to get their utilities over to the unit as well. I will be adding a detailed summary of this on my Substack for things as project managers, what I ran into with this one, and some deeper information on that. So look forward to me adding to that as well. If you have any questions, please let me know. If you like this video, please subscribe. That would be great. Thank you.